Hello and welcome back to Having Fun Repairs. Special treat today. Every Christmas, my wife sits down with the kids and have them pick out 3 toys that they would like for Santa to bring, and then we donate. Have their kids pick out older toys, and they get donated to a charity of sorts. This was an item that my daughter had picked out. She's big into the whole Disney Frozen thing. Yeah, you hear her over there. She loves her Frozen. And so she picked out this little necklace. Got it off of Amazon. It was about $13, $14. Here goes that listing off of Amazon. Covering up my zip code, but you see it's about $14. Anyhow, turn the light back on. It's way too dark over here in a little workbench area. Anyhow, she's a bit upset. She's going around. She kept pressing the button and it plays a little melody, some singing, and it would light up, but it wouldn't sing anymore, so she's rather upset. Occasionally the sound comes in, it's got 2 switch settings off. There's a try setting, then there's an on setting. The try setting, I guess, is for stored display. The melody only lasts for like 5 seconds. The longer one's around 15 seconds or so. But when you're pressing the button, you see it is lighting, but no audio. And you can wiggle things around and it tries to start doing audio. See, it's still on, but then it cuts out. And it doesn't matter which switch setting I have that on, switch 1 or switch 2, it's the same problem. Oh. Yeah, there we go. So more than likely it's just a speaker issue, but we're going to tear this thing down and test it anyways. And of course, anytime you're troubleshooting, you start with the first obvious things, make sure the batteries are good, so check that next. Alright, these batteries tested well. LR44 1.5 volt batteries were all within a good voltage range. So what we'll do next is we'll tear this down even more. tear it apart we shall, and tear it apart we did. And luckily I was able to get that whole thing apart without breaking anything. You saw that this flipped out of my hand at one point. There's a pad at the bottom that was physically stuck on top of the speaker, and when the glue loosened up enough, the whole PCB just flipped right on out, but luckily nothing was damaged. I went ahead and moved these two pads over because I wanted to poke and prod around a bit of the circuitry on here and try to figure out what's going on. I several revisions to little diagrams I was working on, tracing out everything. Finally, I came up with this. Now, I'm not going to say that this is 100% correct because, again, I'm not an engineer or anything, but this is what I was able to trace out. You have your battery voltage coming in, 4.5 volts, your B minus and your B plus. Here goes your B plus from the back, and then your B minus negative terminal from your battery voltage. Okay. Alright, then you also have switch 2 and switch 1. Now switch 1 is going to control whether or not this thing can operate at all. Switch 1 is located on the back. There are 3 positions on this switch. Center is off position. Up, we'll call that position 1, and down, we'll call that position 2. Okay. When in the off position, these center pins, we'll call them 2 and 3, are connected. And you can see that 3 is fed from the positive side of your battery, and 2 goes into this comparator here. When in the 1 position, you're connected to pins 1 and pins 3. Again, 3 positive side of the battery, and 1 directly to this comparator that's in here. It's labeled U1, telling me it's comparator, but there's more than just a comparator, and there's probably, I'll get into it in a minute, there's definitely more going on. When in position 2, meaning fully down, you have continuity between pins 3 and pins 4. So 4 going into U1 and 3 again coming from the positive side of your battery. Now, nothing occurs with just in position 1 or 2. Now recall I mentioned that there is a kind of like a test position, or a position you could put it in to only allow audio through for a short amount of time, and then a position for audio and blinking lights and stuff to occur for a longer duration. When in position 2, that is the test position. In position 1, you're in the longer duration actual play. You also have 2 LEDs, LED 1 and 2. There goes LED 1, there goes LED 2. Current limiting resistors going through the front, 430 ohm resistor fed into LED 2 and 270 ohm resistor into LED 1. You also have your speaker out, so a little 8 ohm speaker right here. And then you have a slew of capacitors tied to ground. I didn't take these capacitors off and test to see how many nanofarads or picofarads or farads they are. They're very tiny, and I could do that and find their value. I just too much work. Look, and the potential of losing one and permanently breaking this thing is probably, considering me, a very highly relative thing to happen. Alright, so you have U1. Some people call this a blob chip. This guy right here. I believe there are several things occurring here. One, I think there is some memory that stores the audio tune that is played. I believe there is some type of audio driver built into here as well to amplify that audio in order to drive the speaker. And I believe we have a 555 timer in here to control how long this thing operates. I think when it's in position 2, that 555 timer, once S1 is pressed, that duration is a lot shorter. More than likely it's probably utilizing these capacitors down here to control that amount of timing that it will be on. But in position 1, that timer runs the full length. Now these LEDs, they flash, they're not permanently on. They flash, they go off, they cycle different states. And I also believe that that is controlled by our VDD in, because I tested this with my little power supply hooked up. Your 4.5 volts is fed to the anode of the diode, and the cathode you're going to see that 4.5 volts as well, until a ground is presented through U1 to either side, and that voltage can then, current voltage is able to go to ground, current is able to flow, this diode is able to be biased and illuminate. The duration for how they blink and cycle on and off is more likely controlled by the 555 comparator as well, which I believe is a part of this circuit. And I also believe that when they kind of like grow, like it's not like an instant on and off, sometimes they ramp up, so your bias is through this diode. If you have 4.5 volts here and 4.5 volts here, this side can't go to the ground, that LED is going to be off. But as this voltage starts to drop, say if it drops not rapidly but slowly, this LED is able to start illuminating, and then will ramp up to where it's fully illuminated. I believe that these capacitors here help in controlling the bias of these diodes and when they flash on and when they flash off. And of course, switch 2 is the one that activates it all. So once you're in position 1 or position 2, nothing's going to occur until that 4.5 volts. When you depress the switch, 4.5 volts is fed into here. Maybe to I don't know, whatever pin on that on this the IC or 555 timer that's in here triggers it to actually start running the course and producing the music that and lights that my daughter so enjoys when she's playing around with this little kid's jewelry necklace. So that is basically it. Anybody who and there's obviously people who will understand more than me. Anybody who does understand more than me, feel free to comment in the little comment section down there and tell me what I've done wrong on here, what I've missed. I'm more than willing to listen. And feel free to visit my website, and my email address is on that Google site. Y'all can shoot me an email. But yeah. So, while I had this apart, figured I start poking around my multimeter a bit and try to test this with my bench power supply. And I had a small discovery. So, turn my power supply on. I've got my power supply voltage set to 4.5 volts. We'll throw this into position 1, switch on the back, and we'll depress the button, and you can see that it's lighting up. Now I checked continuity from the wires to the speakers, etc., and on the speaker itself, and I've jiggled these wires a little bit, and I couldn't get audio to come in until I put pressure just a little bit on this diaphragm, which tells me that the issue with this toy is the speaker itself. Something probably with the coil inside of the speaker underneath the diaphragm. Could be a small break, a small disconnect. Now I could put something on here to hold that in and fix this toy, but I want to see if it'll be economical enough to do a more permanent repair. Remove a bit of this glue that's on the side of the diaphragm, see if it will easily come off and potentially find the break. So I am going to turn on my desoldering, soldering workstation. I will desolder the wires from here and start taking this speaker apart. Okay, so this upper little layer is a no ring compression ring that's used to put pressure on this diaphragm to keep it down. Love you too, bud. You saw me cut away a bit at the plastic here as it was attached to this as well, but one thing that I wasn't paying particular attention to, and I'm not sure if it will be extremely noticeable on this camera, but you can see that there has to be very fine wire running from these two terminals through here. So I'm hoping I didn't cut those wires by doing so, because when I flip it over, and notice I didn't want to damage the diaphragm, because if you overly damage this diaphragm, you're going to mess up how the device sounds. This is a very small 8-ohm speaker, and you can see on the inside that there goes your coil, and here is your magnet, and then if you look all the way back this way, I'm sure I can capture this on camera good enough. Let's get here. See if I can flip this over without having to pull it back up. And without blocking the light from the camera. There we go. Right here you have two wires going into this coil. Now, as alternating current passes through the coil, it opposes or is attracted to the polarity of this magnet, whatever, whether it's positive or negative. And if you recall my other videos, that causes this diaphragm to compress and depress, or compress and expand at a very rapid rate, at the rate of the AC signal or audio signal coming in, and that's what produces your sound. So I'm going to check this with a multimeter real quick, just to make sure I didn't accidentally cut those wires going into there. Just under normal light, and I don't have a microscope and I wear glasses, I'm not particularly seeing any issues with the wires. And again, I was measuring around 8 ohms, but it was the pressure on the top that was maybe the coil wasn't seated far enough on this magnet. You know, this is a very flimsy diaphragm, and I imagine that it weakens over time, and that it's just not close enough to the magnet in order for that movement to actually happen. So I could have potentially broke it, made it worse just by opening it up. So we'll have another way, or hopefully I didn't mess up this speaker too much by opening it up. But I do want to check it one more time. We'll zoom out for a second. There we go. Multimeter set to ohms. And then I'm just going to go across these terminals, see if we still get around 8 ohms. And I may have cut those wires and ruined this speaker, because now I'm getting nothing. Why am I getting an open here? Shouldn't have an open here. There we go. There's just a very fine protective coating or some leftover flux. It's touching the casing of the speaker, the cone, a second ago. That's why it shorted out. Okay. So it's safe to say that I did way more harm than I should have done. And ruined this speaker. Yeah. And you can physically see right there. Zoom in a little bit. Right there, that one of these wires is at least broken loose. This one right here. And it's no longer connecting. Now, you can kind of see it flapping around there. Now, I'm gonna be honest. The likelihood of me repairing that, given the fact I have the world's steadiest hands, is very minimal. I really have to brace my hands very well in order to get this functional. But I do have an idea to at least get this repairable. And the other thing is, these very tiny wires that make up this coil, this very fine diameter wire, is actually very good for circuit board repair, especially running traces, super tiny traces and stuff. So I can keep that. That will be of use. The rest of this can go in the garbage. I do find it easier to repair circuit board traces than it would be to repair that speaker. And ideally, what I want is a permanent fix for my daughter's toy. So what I'm going to do instead, now what's the comparison diameter? Ooh, shouldn't have done that. That is a little bit bigger, but perhaps I can still make this work for my daughter's toy. Have to journal out the case a little bit, but I think I can make this work. Alright, I had to use my Dremel to take out a lot of the inside. Hindsight 2020, I should have just put a little piece of fabric or something on top of the speaker to keep the diaphragm depressed. But I was able to open this up quite a bit and fit in this little Nintendo Game Boy, what was it? DS Lite, whatever it was that it came out of, into here. Of course, I had to sacrifice one opening where a screw would typically go in, that's fine because it fits. This side I can swing over to here, otherwise it's going to block where your on-off, well, essentially three position switch goes to. I'm going to clean up my mat for a bit. Take a break, clean up my mat, and solder this on to see if it works, and if it works, we'll get it all fitted back together. Alright, so just off camera I cleaned up my desk a little bit, went ahead and removed these old leads going to the speaker right here and soldered it into place with the leads going to the board. So let's test out this speaker. So, be positive. There goes my positive lead, negative lead, and we are going to turn on my power supply. Uh-oh. I hope I didn't mess anything up. That kind of scared me for a second. That might have just been some capacitance left. Let's press the button. That's not right. What's going on here? Got not have good enough ground on there. Negative, not good enough. Put the negative lead back on. And my positive lead. There we go. And off. Hopefully I don't get any marks on that for that music. Put it into the test mode and we'll check that out. Alright. Pretty freaking cool. So that's working. I also touched up this board a little bit where these solder points were at. I noticed that there was, from this capacitor C1 to the negative terminal of the battery, it was bridged. Now that capacitor is going to a via on this PCB that goes to negative anyways, but I wanted to at least clean up through here. Sometimes when you have big old blobs of solder going everywhere, that's it's not good for the longevity of your device. But I'm gonna clean this up and we'll get it mounted right back into the little casing, put our batteries back in, and see how it plays out. Alright. And here we go with it all put back together. One thing I didn't account for was the post hole for the screw on this side, so that's why if you notice while putting this back together, I chopped these pieces right here off with a pair of diagonal cutters. Everything went together pretty well. I had to play with it a little bit. There's a gap on the side, obviously, because the screw's not holding it in, so I put down a bead of super glue. My daughter's not going to use my SMD reflow station, my heat gun, to get it to harden up a bit. I'll probably go back through and clean that up just a tad bit. But batteries are in, and we'll power it on. See, that's a all the way up position. And let's play it for a second. Hey. So it does work. It works pretty good. So I think the daughter's already in bed by this hour. I'll wait for her to wake up and give it to her and see how she likes it. Hey baby girl, I got something for you. You like it? You want it on? Yeah, we'll put it on.
You like that, so you put it on. Archie loves it.
Is that good?
Is that good? Also, it loves her.
She's happy.
It is.
Well, there you have it, folks. One repaired necklace and one super happy daughter. If you did anything different, what would you have done? Obviously, you could buy a like-for-like replacement of that speaker and not have to modify the inside of the little toy itself. But I don't know, let me know in the comments down below. If you like this video, give it a little thumbs up. Consider subscribing to the channel and sharing. As always, appreciate you. Thank you for watching. Bye bye.